Magnetars are objects that possess what is the very definition of a superpower. These ultramagnetic neutron stars are so powerful, they can distort the very fabric of space-time and unleash energy blasts that dwarf the sun's output 1,000,000 times over. We are deep diving into the awesome world of magnetars, exploring their mind-boggling power and the many ways they can destroy life on our planet. Magnetars are a rare kind of neutron star, which in itself makes them one of the most extreme objects in the universe. Neutron stars form when massive stars collapse under their own gravity, crushing their cores into dense spheres that are only 5 to 10 miles across. They are the final form of physical matter in existence before becoming a black hole. A teaspoon of neutron star would weigh billions of tons. Now add a magnetic field that is billions of times stronger than anything on Earth, and you have one of the most terrifying objects in the universe. A magnetar's magnetic field is 1 quadrillion times stronger than Earth's magnetic field. That's a 1 followed by 15 zeros. The field is so intense that it distorts the very shape of atoms, compressing them into thin, elongated shapes. It's a near impossible condition that can only happen in a handful of places in our universe. How a magnetar forms remains shrouded in mystery. Scientists believe it has to do with their insanely fast rotation speed, extreme gravity, and conditions inside a newly formed neutron star, combining to create this magnetic monster. So just how fast can a magnetar rotate? The fastest spinning neutron star we've found spins 716 times per second or 43,000 times per minute. In Earth terms, that's over 2.5 million days per hour. Only about 1 in 10 neutron stars become these magnetic behemoths. If the star's initial mass, rotation speed, and internal conditions in its core are at extreme levels, there is a chance it will transform into a magnetar. They can have magnetic fields as powerful as 1,000 trillion Gauss, or 1 quadrillion. That's a couple of quadrillion times stronger than Earth's magnetic field, which is only about 0.5 Gauss. A refrigerator uses a magnet at around 100 Gauss, with the most powerful magnet ever created by humans at 45,500 Gauss. But this is only the start of a magnetar's immense power. A magnetar is so incredibly dense and its gravity so powerful that if it has an earthquake or starquake, it can release ungodly amounts of energy in the form of gamma-ray bursts. These bursts can be detected billions of light-years away, even outshining entire galaxies for a brief moment. A typical magnetar quake can release more energy in a fraction of a second than the sun does in 100,000 years. In 2004, a magnetar located about 50,000 light-years away from Earth unleashed a gamma-ray burst that was so intense it ionized Earth's upper atmosphere enough to disrupt global radio communications. If the magnetar had been within 100 light-years of Earth, the consequences could have been catastrophic, even lethal. A 1-inch shift on the surface of a magnetar is considered to be a massive starquake, a mere single inch. A gamma-ray burst from a magnetar could damage our ozone layer, disrupt the global climate, and even trigger mass extinctions. For now, the chances of such an event are extremely low, as there are no known magnetars close enough to Earth to pose this kind of threat. Neutron stars and magnetars also have the most intense gravity in the universe, with the only exception being a black hole. Imagine a star 10 times the size of our sun being compressed into a ball that is only 10 to 12 kilometers or 6 to 7 miles across. That would be like taking the Earth and crushing it down to about 40 feet. This gives magnetars a gravitational pull that is so strong that if you were teleported to the surface, you would be instantly crushed and flattened to the height of a single atom. The gravity is 100 billion times stronger than that of Earth's, making a 200-pound human weigh 20 trillion pounds. If instead you were pulled into a magnetar by its gravity, your body would undergo what's called spaghettification. The magnetar's powerful gravity and magnetic field would first begin to distort the structure of your body as you drifted closer. You would begin to get stretched head to toe as the magnetar's gravitational pull accelerated you to half the speed of light, or about 100,000 miles per second. you would be torn apart atom by atom, reduced to a long, thin stream of particles and distorted atoms. Its immense gravity would tear you apart at the atomic level, but it wouldn't be over. The thin stream of particles that were once you would impact the surface of the Magnetar and result in a release of energy that would be more than if every nuclear bomb on Earth was exploded at once. Another superpower of a Magnetar is their ability to accelerate charged particles to near-light speeds. This creates a high-energy environment that can produce X-rays, gamma rays, and other forms of radiation that is lethal to any living organism. If a Magnetar were to release a powerful burst of radiation in our direction, it would have devastating consequences for life on Earth. This combination of magnetism and gravity, coupled with supercharged particles traveling at nearly the speed of light, makes a Magnetar one of the most intimidating objects in the universe. They are the very thing that nightmares are made of for astronomers. Magnetars are second only to the might of a black hole in our universe. Their force is so extreme that they challenge our very understanding of physics. They can emit more energy in a few seconds than our sun does in its entire lifespan. Their magnetic fields are capable of warping atomic structures, and their gravity bends the very fabric of space-time. By studying their extreme properties, scientists gain insights into the fundamental laws of physics and the behavior of matter under extreme conditions. These magnetic monsters remind us that there is still so much to explore and discover in the cosmos. As we continue to push the boundaries of science and technology, we can look forward to unraveling the mysteries of Magnetars and other cosmic wonders, expanding our understanding of the universe and our place within it. I'd like to thank you for watching, and we will see you in our next episode.